Right, so today we are going to do Leetcode question 322, coin change. The question says, you're given an integer array coins, represents coins of different denominations, and an integer amount represents a total amount of money. Return the fewest number of coins that you need to make up that amount. If the amount of money cannot be made up by any combination of the coins, return -1. You may assume that you have an infinite number of each kinds of coins. So the first example we have is the coins that we have is 1, 2, and 5. The amount that we need to make up is 11. And then the least number of coins that we need to get 11 is 2, 5, and 1. The second example that we have, the coins is 2 and the amount is 3. And we cannot use coin of 2 to make up 3, so the output is -1. So for this question, we actually can use like an recursion to like traverse to the coins until we into infinity loop until we hit the amounts that we need. So if for each pass, if the current amount is greater than this target amount, we need to just return that path, just stop it. And yes, if it's less than the amount, and then we keep adding the coins for it. But this will take the time complexity for this solution is too big. We need to, I think it should take for each coins we either take it or not take it. So I believe if you assist that it will time out. So we need to use dynamic programming to solve this problem. Like for example, since our amount is 11, we need to find out the least number of coins that we get 11. But to be able to get 11, we need to know like 11 minus 1. What's the number of coins that we need to get? 11 minus 1 and 11 minus 2. 11 minus 5. This is the first example that we are talking about. We have coin 1 to 5. So to be able to reach 11, we need to start from here, I believe. 11 minus 1 is 10. And then here is 9. And then here 11 minus 5 is 6. Yes. So if we use 10 plus 1, it's like another coin 1. And then we reach 11. And then we use 9 plus 2, we can reach 11. And 6 plus 5, we can reach 11. And we just need to take the minimum amount of this and then add 1 for it. That's what we are looking for. So how we are going to represent this thoughts? So we need to first start with, so our initial amount is start from 1, start from 0, and then 1, 2, 3, 4, 5, then up to 11. Then the coin that we can pick is 2, it's 1, 2, and 5. Now we know like as 0 is like 0 is 0, we don't need any coins, so that would be 0. And start from here, like 1 plus 0 is 1. So the amount of coin that we get is like 1 plus 0, we get 1. So we just need to take the amount of the coin from 0 and then add 1 that we get 1. So that will be 1. Then here, 2 plus 0, we get 2. So here that will be 1. Then 5 plus 0 is 5. So here is 1. Yeah. Then we keep going until we hit this. Yeah. So let me see how we are going to represent the code. So first we need a table called dp, so equal -1 times amount. Then dp of 0, that will be 0 for I in range of amount. And then we get index, and for coins in coins, right? So for each coins, when we traverse coin, we use the current int. We use current int plus coins, that will be the current position. So, but if dp of I is equal -1, we need to continue, because if I is equal -1, that means like there's no way that we can reach amount of I. So it means there's no way that we can reach amount of index X. So we need to continue. Or another case is like when the index is greater than amount. If the index is greater than amount, it means it exceeds the size of this array. So we don't need that. So we continue. Then so if dp of the index equal -1, then we just set this equal dp of I plus 1. Else if like this is not -1, means we already has some amount of coin that we can reach in this index. So we need to take then we need to take the minimum of dp of index of the minimum of the previous value with current I plus 1. And at the end, we just need to return dp amount. Let's see if it works. It's out of range. So here we need to add 1 because we need to get the index is at the end. We need to get index of amount, so it means we need to add an extra index for it. So let's run again. So it looks good. How about we submit it? All right, it looks all good. And in terms of the time complexity for this question is that we traverse our amounts, start from index 0 to index amount, and then we traverse, we check all the coins for each index. So that will take bit of number of coins times amount. So if we have, like, let's say we have coins n coins, and then amount is x. So that would be x times n. And then the space complexity is, yeah, so the times complexity that will be O of n times amount. And the space complexity is the size of amount. Is like, yeah. So yeah, so that's this question. Thank you so much. And if you like my video, please subscribe. Thank you.